In the last video, we were discussing about measurement of rainfall using different rain gauges. Today, we are going to discuss about average depth of rainfall over an area. Why we have to calculate average depth of rainfall? Because for the analysis of almost all hydrological problems, it is necessary to determine the average depth of rainfall. If you consider a small area, there may be a single rain gauge station. The rainfall data recorded at the station represent the average depth of rainfall over that area. For a large area, there will be a network of rain gauge stations. As the rainfall over a large area is not uniform, the average depth of rainfall over an area is determined. These are the methods to determine the average depth of rainfall over a large area, that is arithmetic mean method, Thiessen polygon method and isoheital method. First we will discuss arithmetic mean method. This method is accurate only if the rain gauge stations are uniformly distributed over the area and the rainfall varies in a regular manner. Then we can go for arithmetic mean method. In this arithmetic mean method, we are giving equal weightage to all rain gauge station data. Consider this is the area. There are 3 rain gauge stations. Say P1 represent the rainfall data at station 1, P2 at station 2 and P3 at station 3. Then in order to find out the average rainfall data, we can use this equation, that is arithmetic mean P1 plus P2 plus etc. Pn divided by n represent number of stations. Okay, this is about arithmetic mean method. Next method, it is Thiessen polygon method. Consider this is the area. We have to calculate the average depth of rainfall of this area. Say there are 3 rain gauge stations. These are the 3 rain gauge stations. The first step in this method, we have to identify area which is coming under the station A. Okay, area which is coming under the station A. So for that one, first join the station using a triangle. Okay, so here there are only three stations. So draw a triangle connecting the 3 stations. The next step, you have to draw the right bisector. So what is the right bisector? It should divide equally and it should cut the line at a 90 degree. So this is the right bisector. You have to draw the right bisector in such a way that it should extend to the boundary of the area. So drawing the right bisector of line BC, then next one AC. So this much area is coming under station A and this much area is coming under station B and this much area is coming under station C. Then you can use this equation for calculating the average depth of rainfall. P1 A1, P1 represent the rainfall data at station 1 and A1 represent the area. So this is the area. Then plus P2 A2 plus etc. Pn An divided by A1 plus A2 plus etc. An, where the denominator represent the total area which we are considering. Then we can rewrite this equation. P is equal to A1 by A, where A1 plus A2 is the total area. So A1 by A into P1 plus A2 by A into P2 plus etc. An by A into Pn, where A1 by A, A2 by A, it is called Thiessen weights. So this is the equation to find out the average depth of rainfall. The previous example, we have considered only 3 stations. Consider there are more than 3 stations. How to use this method? Say there are 5 stations. First step, you have to connect the station using triangle. So draw triangles connecting these stations. The next step, draw the right bisector. This also represents the right bisectors. So identify area which is coming under station A. This much area is coming under station A and this much area under B, this much area under C, this much area under D, and this is the area coming under E. So this is how we are calculating the areas. Then you can use the previous equation for calculating the average depth of rainfall. Next method, it is isoheightal method. This is the most accurate method. Before going to that method, first we will discuss what is isoheight. Isoheight represents the line joining the points of equal rainfall, or we can call it as contours of equal rainfall. So this represents the isoheights. This data 70-80 represent the rainfall. 70 mm rainfall, 80 mm rainfall. Then this is the area between two isoheights. Say A1, A2, etc. A7 represent the area between the isoheights. Then first step, you have to calculate the average rainfall data in each area. That is, if you consider area A1, the average rainfall is equal to 70 plus 80 divided by 2. So we are getting as 75. Similarly, we are calculating the average rainfall for each area. Then this is the equation to calculate the average depth of rainfall. P is equal to area between two isoheights. Say if you consider this one A1 into 75. Mean of two adjacent isoheight value divided by the total area. That is total area of the land we are considering. Considering this figure, the equation will be A1 into 75 plus A2 into 85 plus A3 into 95 plus etc. divided by the total area that represent the average rainfall data. This is about different methods for calculating the average depth of rainfall. Next we will discuss the problems.